Alright, so evaluate quadratic functions. Understand the meaning of solutions related to the graph, which means if we look at a graph, we can tell how many solutions we're going to have. And then we're converting equations between standard and vertex when a is greater than 0. Alright, I should say a is greater than 1. Because we did a is 1 yesterday, right? We never had anything that was bigger than that. Today we're going to see what we're going to do if a is bigger than 1. I don't know what you guys are doing. I'm kind of hoping that like Quentin falls over and he has big knockouts. Alright, so first we're going to do, really easy, evaluating quadratic functions. Just like we evaluate any function. If I have f of 1, what should I do? If I have f of 1, plug 1 in for x. So I'm going to figure out what both f of 1 and f of 3 are separately, and then add them together. F of 1 equals 3 times 1 squared minus 2 times 1 plus 5. 1 squared is 1 times 3 is 3. Minus 2 plus 5 should give me 6. So f of 1 is 6 plus f of 3. 3 times 3 squared minus 2 times 3 plus 5. 3 squared is 9 times 3 is 27. Minus 6 plus 5 should give us 26. So 6 plus 26 will equal 32. So, evaluating quadratic functions is just like evaluating any other function. We take our number, we substitute it in for x, and in this case we find them out separately and add them together. Pretty simple? Check one thing off. We're done with that already. Pretty easy. The next thing you're going to need is a graphing calculator. You will need a graphing calculator for the next part. So, finding the solutions of a function, finding the roots, finding the zeros, finding the x-intercepts of a function. We talked about this already. They all mean the same thing, right? These are solving for x. We're trying to find the solutions. So, we're always trying to find the value of x when the function is equal to 0, or when y equals 0. Right? Where y equals 0, we have x-intercepts. Now, it's really easy to figure out when we're going to have what type of solutions. Right? We said we can have real solutions, we can have complex solutions. We're also going to have one real solution. We will never have no solutions. It should never happen. So, f of x equals x squared plus 8x minus 33. We see it hits the graph twice. Right? It has two x-intercepts. If it crosses the x-axis twice, touches the x-axis twice, it's going to be two real solutions. Right? So two real solutions when it crosses it twice. Okay? We're going to have two complex solutions. What does that mean? What does complex mean? We're going to have imaginary numbers in our solutions. We're going to have two imaginary solutions, or two complex solutions, when it never crosses the x-axis. So you'll see it's either above or it's completely below the x-axis. It never touches it. So we're going to have two complex solutions if it never crosses the x-axis. And we're going to have one real solution if it touches it only once. You'll see the vertex is on the x-axis. So there may be a point on a really important part of this unit where we give you like a graph, we say, or we give you an equation, we say, how many solutions and what type of solutions are you going to have? There are three options. One real solution, two real solutions, two imaginary or complex solutions. If you ever see no solution, not an option. You ever see one complex solution, not an option. There are only three options. One real, two complex. Alright? So, if we give you three equations like this, we ask you, go into your graphing calculator. Let me pop mine up. Go into your graphing calculator under y equals. Oh my goodness.
Spider-Man.
Nice background, Mr.
Thank you, sir.
Can I borrow? Are you a Brewers guy, Mystery?
No. I just really like the M they make.
You know they're changing the stadium?
Yeah, they are changing the stadium because Miller won't pay as much as the other place. Pretty simple. I don't know if you're one of those truthers like, no, it has to be Miller Park.
I never said that.
I didn't know if you're one of those people. Alright, so, you are?
No, I just kind of wanted to go against whatever you said. Just to
Well, maybe I'm one of those
Stop
people.
interrupting our math class.
We can argue about this later, Jalen.
Alright, sounds good.
Quentin
Alright.
needs to learn.
In y equals, you're going to take and you're going to put your equations. So, our first equation, 2 parenthesis x minus 3. Oh, that's not minus. Minus 3. Where am I now? Squared. Minus 5. Why is this not working? Alright. I want to go to the graph and I want to see how many times does it touch the x-axis. So, second graph. Oh, I don't want second graph. I just want graph. Sorry.
Who's zoomed in, Mr.
I'm zoomed in.
Mine's not working.
Probably because you don't have a great window. So what I would do, if I was you guys, I would hit zoom in the middle. I'd go down to standard. Z standard. Go to 6.
Oh, that works.
And it should graph. How many times does it hit the x-axis?
Twice.
Twice. So that means it's going to have 2 real solutions. That's not it. That's it. 2 real solutions. Alright, what I want you to do the next 2 in your calculator. Figure it out.
Zero down. Two button. Talk about the edge.
Yes.
How about your...
You're talking about
I just turned the stat plot off. It didn't make me do that, but for some reason it made you do it. Did you same error?
525 was also
Yeah. So guys, you might have to turn your stat plot off. So when you're in y equals, if your plot is on, if you have plot 1 highlighted and you have stuff in there, it's going to give you an error. So just turn that off. Go up there, hit enter on it. Alright, I put all 3 of mine on here at once. So if you look, our second equation, never touched. What does that mean? Too complex. And our last one, only touches at the vertex.
only one real solution.
One real solution. Alright? Any questions on that?
No.
Too complex, one real. Sweet. We're killing it. No questions?
Let's keep the ball rolling.
Cool beans. Alright. Vertex is standard. So, once again, this is the easy way to do it. So, we're just going to do the same thing we did yesterday, except after we FOIL, we're going to distribute our A value through. Okay? So what it's going to look like is there's no longer just a 1 here. We have a 4, we have a 2, -2, whatever it might be. We're going to do everything the same way. Y equals 4, and then in parentheses I'm going to do x plus 2 times x plus 2 minus 1. Right? I'm trying to separate in two pieces so I can FOIL it, just like we did yesterday. Right? So take x plus 2 squared, separate it, make it multiplication again, and then FOIL. First, outside, inside, last. Y equals 4 times x squared plus 2x plus 2x plus 4 minus 1. Now, you could either distribute your 4 at this point. What I would advise those, combine your like terms first. Y equals 4 times x squared plus 4x plus 4 minus 1. Now, if you can obviously skip from the first part down to the second part without writing that intermediate step, go for it. You don't have to write down every single step if you don't need to. Some people might need to though. So, once you're here, once you combine your like terms, take your 4, take your a value, distribute it through to every single piece. Y equals 4x squared plus 16x plus 16 minus 1. Now I'm going to get my last step's going to be 16 minus 1. So y equals 4x squared plus 16x plus 15. Perfect. So the only thing that's changing from yesterday, guys, from going from vertex to standard, is after we FOILed, we have to distribute our a value. Okay? Does that make sense?
Yep.
You want to try the second one on your own? Alright, go ahead and do it. I'll do it on the board while you do it. How do we do? Good. So. Good. So.
Great.
Good? Any questions?
Nope.
Alright, like I said, going from vertex to standard is normally really easy. Going the opposite way is not as easy. So, going from standard to vertex, just like yesterday, is going to be a little bit more difficult when a is greater than 1. What we're going to do is I'm still going to split these. So does it split it right away? No, what I'm going to do is I'm going to take y equals 4x squared plus 16x plus 7. Just like I did yesterday, right? I took those first two terms, put them in parentheses and left a space, plus 7. Then what I'm going to do is I'm going to factor out whatever GCF I can take out, but I'm not going to take the x. I'm only taking a GCF from my integers. So like here I have 4 and 16, I can take a 4 out of both. So I factor out a 4, I'm left with x squared plus 4x plus whatever. Right? What I'm left with in here, I'm going to do just like I did yesterday. I'm going to complete the square. So I'm going to take 4. Divide it by 2. I get 2. And then square it. 2 squared equals 4. That might be down here. So I'm going to add 4 on the inside. But hold on. You cannot just subtract 4. Am I going too fast? Are we good? Okay. You cannot just subtract 4. Why can I not subtract 4?
Because you have to distribute.
What's that?
Because you have to distribute the other 4.
Because if I distributed this, it'd be what? 16. So I'm going to subtract 16 off the outside. What you're going to do, whatever you add in the inside, you're going to multiply by whatever number you pulled out, and that's what you're going to subtract by. Okay? So if we distribute this back through, it'd be like adding 16. So subtract 16 on the outside. Oops, it's already on there. And you see, yeah, we saw that. Alright, and then the last step, factor the inside part. Right, just like we did yesterday. X plus 2, x plus 2. Then it becomes 4 times x plus 2 squared minus 9. So split it up just like we did yesterday. Take out that integer GCF. So we took out a 4. Then complete the square, add on the inside, subtract on the outside, and factor. We okay with that? Do we have any questions?
Nope.
Do we all have that written down?
Yep.
Should we try an example or two? Okay. So, first thing I'm going to do, like I said, take 3x squared minus 6x, break it off, then plus 6 on the outside. Leave that space. What am I able to take out of these two terms? 3. So it becomes y equals 3 times x squared minus 2x blank plus 6. Once you've taken that integer out, negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So I'm going to add 1 on the inside. X squared minus 2x plus 1 plus 6. But I need to subtract what on the outside? 3. So I got to do 1 times 3. So I subtract 3. Factor what's inside here. Y equals 3 times x minus 1 squared plus 3. Okay? Does that make sense? Yeah? Alright. One more together. Y equals 2x squared plus 6x plus 11. Patty,
Yep.
what am I going to take out of 2 and 6?
You're going to take out a 2.
Take out a 2. Y equals 2 times x squared plus 3x plus 11. Alright, we're going to take that 3. 3 divided by 2 is 1.5. Using decimals, I'll go on. 1.5 squared is 2 point, what? 2.5. So, inside, I'm adding 2.25. Outside, I'm subtracting 4.5. Right? 2.25 times 2. We all see that?
Yes.
Okay? So I need to factor this now. Y equals 2 times, what does it factor to? Remember that trick we learned yesterday? Where we said what's going to be inside here is always whatever we took and divided by 2. So what should be inside here? X plus 1.5. X plus 1.5 plus, 6.5. So you have y equals 2 times x plus 1.5 squared plus 6.5. Wow, you guys did decimals. Good job. Does that make sense?
Yes.
Do we have any questions on that? You have 2 problems to do on your own. One is converting to vertex form, one's converting to standard form. You want me to leave these up here?
Yeah.
Okay. Appreciate that would have been if I forgot to do that. If you have a question, raise your hand. I'm more than happy to help you. Guys, don't lose that number you take out. Right? You said, yes, was it in here? Where I gave you the reference of taking your sibling to the mall and losing your sibling. What? Very relatable, right? Don't lose those numbers.
I used to go to Walmart and get lost on purpose.
Sure, yeah.
How'd you do?
Front desk.
I don't know.
And I'd tell my mom. And then I have them call my mom up there.
I bet your mom loved that.
One time she kept shopping though.
Well, you cry wolf enough, man. Alright, check your answers, please. Let me know if there are any questions.